So gloss. It's a mode of appearance. That means that it's a visual sensation first. And we talk about reflect that are highlights on the surface. For instance, here you see, here I see the reflection on the surface. So this one is more glossy than this one, which is more glossy than this one. That's what we need to measure, that kind of sensation. And that's also a part that is important. Before we measure it, let's just take a few minutes to discuss about what gloss is. So gloss is present in our daily life and is highly implicated in our cognitive process. Here, for instance, you are in a room, you don't see the light source, but you can find the light source thanks to the gloss that you organize around you. The same here, for instance, this is a painting. You don't even have to know where the painter was, because you can even already take information about the fact that there was a window and in the room, and this even if you don't see the window, thanks to gloss, in fact. And you are used to do this. You do it always in your life since you are young. The gloss allows you also to detect the curvature and the shapes. For instance, here you can see this is not a white dot. This is a specular reflection of the sun, and then you know that there is a convex surface here. But also, thanks to gloss, you can get information about the material itself. Here, it's not exactly the same color, but you see the plastic and you see the fruit, and it's not because of the shape, it's because of the gloss, in fact. And finally, gloss is connected to the sensation of quality. And so that's why it's important for industrial to measure it. So let's try to measure gloss. The first thing is, if I take the previous picture and I ask you, can you rank those samples from the matte to the glossy? In fact, you can. You can say that this one is matte, this one is matte, this one is a little satin, this one, then it's this one, then it's the fruit, then it's the lips, for instance. Or maybe you disagree, but you can justify and you can rank them. So if you can rank the gloss, we can measure it, because that means that in your brain there is a scale somewhere, and it's just now a matter of finding the scale. And how we can measure it, the best is to look at how the observer does. And of course, I have an observer. So I give him 2 samples and I ask him which one is the glossier. And he can make it again, so I will do another try because that was too fast. But it's the end of the day and he's not naive. This one again, okay. So did you see? Do you trust him? You trust Lionel. I trust Lionel too. And what does he did? In fact, I don't really care about the result. What I care is to see how he did. And the first thing he did is that he looked for the light. And then he moved the samples because he tried to catch the specular direction, and then he evaluated the reflection around the specular direction. If I had him to not touch the sample, then he would have his head and try to find the good angle and then move the head again and then evaluate the things. So in fact, mainly what I can conclude is that gloss can be ranked. If gloss can be ranked, it can be measured. And mainly if I look at the observer, the information is around the specular direction. So let's see now what happens on the surface. The surface is like this. When you illuminate your surface, one part of the light is reflected at the interface, another part is transmitted, then it can be absorbed, it can be re-emitted, it can be transmitted. That part we don't care for gloss. We care only about that part, which is the light that is reflected by the surface. If it's a perfect polished surface, then all the light we reflected will be in the specular direction. And I can even compute the reflectance factor if I know the refractive index. But for real surface, it's not the case. In fact, the light hits different parts of the surface, and then it is reflected mainly in the specular direction, but not only in the specular direction according to the normal of the sample. And at the end, what I will collect is something that is like this. It is mainly reflected in the specular, but according to the roughness, I will find light outside the specular around. That's what we call, if we measure the light in the plane of incidence around the specular, we will get a peak. This is the specular peak. Okay? This is a specular peak, a real one, not a modeled one. So if you put a detector and you illuminate here at 21 degree or 20 degree, then you get the specular. So it's not a black sample, it's a gray sample, because we can see there is a little diffuse light here in the feet of the peak. But then you have a peak. Few things to know about the specular peak, because a lot of people talk about it, a lot of people use it in computer graphics, but there's not a lot of people who measure real peaks, so it's good to see. The first thing is that the specular has the spectrum of the lighting for non-metallic surfaces. So about the color, we don't really care. In fact, we just have to know the color of the light source. The second thing is that the size of the peak increases with the refractive index of the material. This is due to Fresnel, and also the size of the peak increase when the illumination get the zenith angle increase. Here you have 3 zenith angle, and you see it's quite a very big effect, in fact. So the size of the peak is very dependent on the azimuthal angle. The size of the width of the peak and also the size depends on the roughness. Here it's 2 samples, one very rose, one more glossy. And be careful, this is a log scale here, so this is decades, for 4 decades here. So in fact, this peak is really, really big according to this one, because the roughness is different. Something that is people don't really always know is that you don't necessarily have the maximum of the specular in the specular direction, particularly for matte surfaces. You see here, so it's not because you make your setup not saturated in the specular that you're not gonna saturate it on a more grazing angle. And it's true more for matte surfaces. It's also more true when you increase the zenith, then it's even at 60 degrees. This is the blue one, and you see we are completely off. And here I can't do more, but maybe it goes even more higher at grazing angles. And one last thing is for glossy surface, very glossy, the peak can become very narrow. Something like 0.78 degree for the full width of half maximum, so it's something very small. And at the opposite, it's getting also very tall. It can go up to 4 decades maybe. This is for glossy surface, but it's also for not mid-glossy surfaces. Here we measured the width at half maximum of the peak for different level of gloss, going from very matte to very glossy. And you see, even for mid-glossy sample at the middle of the scale, the width is already about 5 degrees. So it's not that 5 degrees, it's not big. And one last thing, yes, more, is about the material. This is something we did with 2 different materials, a tire tube and a black ink paper. And we could see that we had almost the same value of gloss with the gloss meter that I will talk about later, but not the same shape. And I really believe that we have a sort of a database of specular peak in our brain, and we can identify like this some materials because they have a signature that is embedded in their specular peak. So where are we now? Gloss is around the specular direction from the optical approach. We know that around the specular direction, there is a peak. And so if we want to measure gloss, we will try to measure the specular peak, in fact. And then we'll see what happens. So that's what does the gloss meter. The gloss meter, this is a device that has an illuminate the sample from a given direction, and then in the specular direction, you have an aperture, and you collect the light that is going through the aperture. So if it's a very glossy surface, you will get a lot of light. If it's a low gloss surface, you will get less light because the light is spread in the hemisphere, so you get less inside the collection aperture. So this is interesting because it's reversed. And this is the same, but with the stuff. It's very simple. You take a light source. It's a source, an illuminant C from CIE. Look at this because it's probably the only one you will see the illuminant C. It's a bluish light. And I don't know why they choose this, but it's in the standard. So this definition comes from the ISO 2813, and this is the standard to develop a gloss meter. Here you have an optical system to collimate your beam. And then you have here as a detection with, again, an optical system to take the light collimated here. And then you have the aperture here. And then you have your detector. And you make the measurement. And the measurement is expressed as the ratio between the value reflected by the standard on the value reflected by the value reflected by the sample on the value reflected by a gloss standard. And the gloss standard is defined as a given material, highly polished, which means, I don't know, perfectly polished maybe in the hypothesis, plane with a reflective index given by this number, and you have to make it. If you don't make it, which is what we do in National Meteorological Institute, because there is no black glass with exactly this reflective index, what we do is that we use usually a fused quartz edge, because this refractive index, we can measure it very well, and then we do the correction. That's how we get the best results. And then when you have you do the measurement on the standard, you do the measurement on the sample, you do the ratio, you multiply by 100, and you have the gloss value. And that's for the gloss meter. So this work has been done by Hunter, in fact, which is a very famous scientist that has worked on the measurement of appearance in 1936 for the publication and 39 for the standard. A bit later, mainly the textile industry complained because because they have very matte surfaces, so the measurement was not sensitive at all for them. So they asked for something better, and in the ISO, they put this configuration at 85 degrees. So 85 degrees is very grazing. And but then even on very matte surface, you get something. And this is the second geometry of the gloss meter. And at the same time, there was also the automotive industry that was complaining because they were measuring very, very glossy surfaces. And at 60 degrees, the peak was too narrow, and the sensitivity was not good at all. So they put another geometry at 20. Then the peak is a little larger, and the aperture has been reduced. So all this is put in the ISO standard. You have the definition of the size of the aperture. It's a rectangular aperture, in fact, in the gloss meter. It's not the same thing in the zenithal and the azimuthal angle. And it's not the same for the 3 geometry. And you have also a lot of other standards if you want to, according to your industrial field, because the paper industry, the automotive industry, the cosmetics, they have all developed the food. They have all developed their stuff, so I put them here just to impress you and to save slides. But at the end, if I measure those 4 samples with a gloss meter at 60 degrees. I got these values and correlates with your sensation. So it's not bad. If we do a more psychophysical experiment, and this is 2 examples, for instance, one with one method, another with another one. But we see that the correlation between the sensation and the measurement of the gloss meter has always this shape. And that shape can be separated in 3 different parts. The matte part, where the gloss meter is not appropriate, because you see that the visual system is very sensitive, where the gloss meter is not sensitive at all. So in this part, probably the gloss meter is not really the good instrument. Observers take other cues, in fact. They look much more at the lightness of the surface, because for matte surfaces, there is no specular. So your visual system is not looking at a specular, is looking at the way the color goes deeper and deeper. If it's a very matte material, it will, even if it's black, it will look gray. And then when it starts to become more glossy, it becomes more black. At the other extremity, we have the same problem. The sensitivity of a gloss meter is not really good, according to the sensitivity of the human observer. This is because in this part, you really see it's very high gloss surfaces, and so you see very well the reflection. And in fact, you're not accommodating, you not accommodate on the surface anymore, you accommodate on the image of the light source. And then what you judge is not really the gloss, is the deformation of the image of the source here. You see the source, you see the word gloss here, and what you're evaluating is how blurry it is here. So it's not the same visual strategy. That's what we call the distinctness of image. And the gloss meter is not sensitive to this. It's very cognitive in this for you, so it's very strong. At the middle, it works well. It's linear. It's a region of gloss where you don't exactly know where to accommodate. So your sensation is not, the system is not very performant, your visual system, and the gloss meters does the job. Oh, I put it at the wrong place, but this is, so for this part on the distinctness of image, there is also normalization and device that are proposed and that you can use. So I'm saying a lot of good things about gloss meter, but in fact, if you know me, I'm always complaining about gloss meters because there is a lot of limitation that I will list now. The first one is that there is 3 geometries, but there is no link between the geometries, in fact. So you can have samples that are completely inverted with the gloss meter. You don't get the same ranking according to the geometry, which is a problem I found. The second is very metrological. This is studies of a lot of gloss meters that has been, it's samples that has been sent to industrial who were traceable to NIST with their gloss meter, and they were doing the measurement on the same sample, and we get that kind of spread of the results, which is, here you have something between 35 and 40, so 5 units on the scale of 100. 5%, it's for people who are traceable, it's not really good. And it comes mainly because the rectangular aperture are too large, and in the standard, the definition of the tolerance on the aperture is made in a way that even if you do your best as an industrial, you will get, and if you respect the tolerance, it can give, and it has been done by the simulation, difference of gloss of 2 gloss units already in the standard. One last thing that is interesting is when you have special samples, sometimes you get a complete inversion between the sensation of gloss and the measurement made by the gloss meter, the visual perception. Those 2 samples are inverted, in fact. So it works, but For instance, in the math part, it's really something you shouldn't use, but you don't have the choice. You have just one instrument. And the last thing is also studies that we have done in my lab, where you get samples very special also. These samples that has been developed by Guillaume with Saint-Gobain, they are special. And you see here, they have almost the same gloss, but this one has a very high peak at the middle, which is not really, it is very narrow, so there is not a lot of energy here. And so the gloss meter doesn't see it, but your visual system see it very clearly. And they have a clear different nature, but the gloss meter doesn't see it. So are we happy? Well, we are almost happy, but there is things to improve. But at least what we can say is that the gloss is linked to the specular peak. We can develop easy device to measure the peak, and we get something that is not too bad at the middle of the scale. That's what we have today. Now we'll talk about other routes maybe we can think to develop gloss. And I'm at 21 minutes. So the first thing is, and I talked about it this morning, that gloss is a multi-variable quantity. In fact, there is no way to put the gloss on just one scale, as does the gloss meter. For instance, if you change the color, you change the sensation of gloss very clearly. So here you have the same specular peak. It's just that you change the color of the sample and you see that the gloss, the visual gloss increase. So there is a contrast effect that is linked to gloss. That's what I put here. Another example is that kind of effect where you have also almost the same specular, but this one has something more like maybe translucency. We call this, in the world of gloss, we call this haze. And the haze changes the sensation of gloss. It can be measured with a haze meter, which is also something defined in an ISO standard, where you do the ratio between the light that is at the middle and the light that is on the side of the specular peak. And you see this one will clearly have a haze higher because on the side of the specular, you have more light that is reflected. In fact, if we look at Hunter's work done in 1936, I don't know why I put this. It's because it's another edition, but the first edition is is really in 36. He put the hypothesis that for gloss there is 6 different classes: the specular gloss measured with the gloss meter, the contrast gloss, the balls that I have shown you, the sheen, that is a special effect at very grazing angles that you can observe on textiles, the distinctness of image, I talk about it. The haze also, and the non-uniformity, it is mainly the orange peel, which is an effect also very characteristic that you can identify when you look at the surface. And I will finish with this part because it's very interesting to understand gloss maybe. So the gloss comes from a source, an object, and an observer for sure. We can look at gloss according to the light source. And it is interesting, it's a work that I have done in the past. I mentioned that when you change the direction of illumination, the specular peak change. This is the same sample, but 2 directions of illumination, and of course, the peak is higher when the zenithal angle increase. It's the same for a more glossy surface, the peak is higher. But if we test the observers, the sensation of those samples at the 2 different angles, in fact, we get exactly the same curve. Those curves are superimposed, even if the peaks are very different. And that means that, in fact, you're not sensitive to really to the peak. You're sensitive to something else because here the peak change and the sensation remains. That's what we call the gloss constancy. That means that even if the direction of illumination change, here I'm looking at the light here, I have an idea of the gloss. Now I'm going here. The peak is completely different because I'm not in the same direction, but in my brain, the gloss is the same. And it's normal because since I'm born, I know that it's not, the gloss is a property of the material, and it's still the same sample when I move it in the room. So I have learned how to compensate probably those different evolution of the specular peak, and I exactly as we do for color with the color constancy. This is what I have shown you this morning, the color constancy when I was changing the blue filter. I have learned to compensate the variation. So in fact, you don't have to put your observer in a shim rest or whatever. You can just leave your observer free. It will give you something on the gloss of the sample, whatever is the direction of illumination. One thing that is interesting is that your observer see better the gloss if it is illuminated by a natural lighting. And it goes in the same way, in fact. If you have learned to compensate the variation of the direction of illumination, but if it's not a natural environment, then it's more difficult because you don't have the cues, in fact, around you. So this is something that has been done by Fleming, and a few years after by the student of Fleming, who did the things in another way, but it's the same thing. You see, it is a simulation, but there is natural lights, and there is lights that, like those one, the window, for instance, and there is lights that you will never see in reality, and then it gives you a sensation of gloss higher when your sample is seen under a natural condition. This is interesting. Another thing done by Guillaume also during his PhD was, we said that, oh, so the observer is not sensitive to the direction of illumination, but is it sensitive to the solid angle of illumination? What if I put my observer looking at the sample under a nice sunny day and under a cloudy sky, for instance? Is it able to recover the sensation, the gloss, the properties of the material? In fact, yes. So you can see there was different lightings, and we could simulate a cloudy sky or a sunny sky in different environments. And what we got is that there is a constancy on one part, but there is also, when you start to have a very diffuse sample looked under a very diffuse lighting, then it starts to be very difficult to find the gloss because it's too complex. It's fine. You multiply the problems. So the gloss constancy is broken for matte sample under a diffuse lighting. That was the conclusion. The shape has an influence on your sensation of gloss. For instance, here, if I apply these specular properties on this dragon here, I will have a sensation that the dragon is glossier than the ball, where in fact this is the same optical properties. And if I want to match this level of gloss, the observer will put this, which is less glossy than the ball. So because it's a natural object and you're used to work with gloss on natural object under natural lighting, all this is coherent, in fact. I'll skip this. And another thing that is interesting is what we call the orientation congruence. When you look at a shape, you expect to get the specular somewhere. If it's not at the right place, you don't even see gloss at all. This is not possible that the light is coming from the bottom, for instance. It's not in your brain. So you say, no, this is something else. This is a scratch on the sample. But it's not gloss. So you expect to get the specular somewhere, and it has to be there. Otherwise, it's suspect. So I already mentioned it. Gloss is a multidimensional quantity, maybe 2 dimensions. That was the assumption of Fairweather, maybe 3 dimensions. That was the assumption of Guillaume. We don't know it, maybe it's more. We'll see. We don't know so far. And the last thing is about maybe one thing that is important is that gloss is what we call a second order attribute. It's taken by your retina, but it's processed by your brain. For instance, here you see the gloss of this car, but in fact it's not. There is no gloss here. The wall is white and matte. It's just color that you see, and you reconstruct. According to the scene, you reconstruct a reflection of the sun here, but it's just a white painting, because this is a full painting made by an artist with matte painting. But it works because you process this information. And it might be difficult at the end to try to measure something that is processed at a so high level by the brain, because we know that our brain is very good, but it's very complex also in the way it does the treatment. And we can see today I've done a lot of measurement of gloss because I'm working on this since more than 15 years. And I start to feel that maybe it's not really the good way to make BRDF measurements, look at the specular, because in fact, I can see that gloss is not really in the specular. The peak change, the gloss doesn't change. So there's something else. And there is proposals by the other teams saying that maybe we should take gloss as a more global visual attribute using an image-based approach and trying to see exactly from the holistic approach, in fact, so coming from really, I take all the information and then I see in this very complex information of appearance, where is gloss in the image. And this thing is probably new roots. I don't know if it will give something, but it's something interesting. There is work that are done on image-based, and then people are looking at information and they can find index that are correlating with the sensation of gloss. This is the screwness, this is the histograms of the luminance or whatever. I put the paper so you can have a look. And to conclude, gloss is an optical properties of a surface. It's a second order visual attribute. It is implicated in the cognitive process. It can be accessed by measuring the specular peak with a gloss meter, doing BRDF measurement. Doing BRDF measurement, be careful, it's not easy. I will talk about it tomorrow for the speckle session. And gloss is influenced by the lighting, the shape, the color. We have the gloss constancy, I talk about it. Gloss is probably multidimensional. We don't know today the dimension, and maybe an approach from a more holistic approach can, in the future, give a good